Hello, Nakamatsan desu. Welcome back to my channel. In this video, we're going to find areas under the normal curve. Specifically, areas less than or greater than z and between two z values. Let's take a look at this figure or illustration. It's based on the illustration of empirical rule that was mentioned or discussed in the previous video. So you can see that the areas here have been divided equally. Example, from -1 to +1. Remember in the empirical rule that the data, 68% of the data lies between the one standard deviation. So you can see that it has been divided from 0 to -1. You have 34.13%. Actually, it has told you before, it's not exactly 68%, no? So from 0 to -1, you have 34.13%, and from 0 to +1, you have 34.13%. Okay, same with this one. From 0 to -2 and 0 to +2, you can see that the areas in between two z values, for example, -1 to -2, +1 to +2, are the same. Okay, this is because your normal curve is symmetrical about its center. It is one of the properties. Okay, here. Okay, it is one of the properties of a normal curve. Okay, there you go. So there is a symmetry. So the area, remember the total area is 100%. So since it is symmetrical, so from 0 to the left side you have 50%, and 0 to the right side you have 50%. Okay, so let's go now to the steps in determining areas under the normal curve. So you have here 7 steps. So number 1 is you need to draw the normal curve. So it's important that you have an illustration, because you can just determine the areas by just imagining what the normal curve looks like. Okay, so you need to draw and then locate the z value and draw a line through the z value and shade the required region. Then you use your z table to solve or to find the area that corresponds to z. Then you examine a graph, and then the last is make a statement indicating the required area. Now let's go to the notations. So in determining the area or the probability under the normal curve, so you have here 3 notations. So the probability that the z-score is between two z-scores. For example, the first z-score is A and the second z-score is B. So this is the probability notation. Then if the z-score is greater than A, so you have here the probability of that z-score is greater than A, then the probability that z-score is less than A. So you have here an example. If you are given two z values, the probability notation between these two z values is you have here probability, the probability that the z-score falls between z equals 1 and z equals 2. So the area or the probability is 0.1359. Okay. Let us have an example. By the way, there are 5 cases that we're going to discuss. So in this video, we're going to discuss case number 1. In case number 1, the area or the required area as depicted by the shaded regions under the figure are a greater than, at least, more than, to the right, or above of z. By the way, these are the keywords. So basic in simple explanation, okay? Case number 1 is about the area greater than z, okay? So, by the way, in our solution, we're going to either subtract or add 0.5, okay, to get the required area. Okay, why? Why 0.5? Because in our the table, the z table that we use or we're going to use is the z table from 0 to positive 3. So that is half of the normal curve. And remember, half the area or a half of the area is 50%. Okay, so that's 0.5. So that's why we're going to either add or subtract to get the required area. Okay, now we have here, by the way, 2 illustrations, no? So for figure 7.1, this is an example wherein your z is negative. So greater than z. So we have here from this one, no, this shaded region. So you can see that it is much larger than this part, and it is more than 50%. No, this line here serves as your the line that divides the normal curve into half, no, or divides it equally, so 50 into 50%. So it is more than 50%. In that case, no, we have negative z, and you need to find the area greater than negative z. What you're going to do is to add 0.5, no, because the area based on the illustration is more than 50%. So you add 0.5, this one, and the area from 0 to negative z. And in this figure, you can see that the given z value is positive. So the area greater than z is the shaded region. And based on the illustration, that shaded region is less than z. No, sorry, less than 50%. Okay? So in that case, we're going to subtract 0.5 minus, okay, what area you're going to subtract? Okay, this area from 0 to positive z, no? Because if you're going to subtract that one, no, this is the half minus this one here, minus this one. Okay, you will get this part. Okay, so that's the idea there. Okay, so let's have an example. So example number 1, yeah, above z equals negative 1. So you have the normal curve. What you're going to do is to locate your z. So where is negative 1? So it's here. Then you're going to draw a line through the z value. Okay, there. And then you shade the region so it's greater than, so that means to the right of negative 1. So you're going to shade this part. Okay, now since we have a negative z score, so we're going to add 0.5. Okay, and you can see in our illustration now that the shaded region is more than 50%, more than half of the normal curve. So we're going to add 0.5. And the area from 0 to negative 1. Okay, because it's 0.50. So to get the total, you add here this from here to here and from here to negative 1. So look at your table. By the way, you're going to look for z equals negative 1. So you write that into 3-digit form first. So in your previous video, if you have a whole number, so therefore there are zeros on the right side. So we have two zeros, that makes it negative 1.00. And that's the same with positive 1.00. The area is the same with 1.00. So look for 1.0, the first two digits, and the third digit is 0. So you match it. So you have here 34.13 or 0.3413. Okay, add, you have 0.8413. So that's the total area. Now this is right, 34.13%. Okay, let's change the color so you can see it clearly. Okay, 34.13%. Okay, so that's from 0 to negative 1. 0 to 3, 50%. So total is you have 0.8413. Then if we're going to multiply 100%, that becomes 84.13%. Okay, so let us summarize. So for the probability notation, write it as probability that z is greater than negative 1. It's equal to 84.8413 or 84.13%. Okay. Next. Number 2. For number 2, let's have greater than z equals positive 1.5. Okay. So you already have your normal curve. Next is you locate this z-score 1.5. So that's between 1 and 2. So here, 1.5. Okay, then draw a line through the z value. Then shade the region. So that's greater than z. That means to the right. So in this case, since the shaded region is less than 50%, so to get this area here, you're going to subtract. This is your 50%. Subtract this and this area from 0 to 1.5 to get this area. Okay, so you have 0.5. So we're going to look for this one, the area 0 to 1.5. By the way, you can write that as 3-digit form, 50. Okay, so in your table, look for 1.5. So you have here, then last digit is 0. So that's 0.4332. Okay, minus 0. Okay, so let's subtract this one. So what is the answer? Okay, 0.5 minus 0.4332. Okay, that's 0.0668. So if we're going to multiply it by 100%, okay, that's 6.68%. So the area, or the probability that C is less than it's greater than 1.5 is 0.0668 or 6.68%. Okay, so that's it. Okay, see you in my next video for case number 2. Thanks for watching.